Okay, we're working on the planning workshop, solving an exercise of an absolute value function. We already did step 1, the table of values using the turning point. The step 2, the graph. We already did also step 3, both x-intercept and y-intercept. We're going to do now steps 4, 5, and 6. So we're going to begin with step 4, the domain and the range. How do we identify the domain? The domain is basically trying to capture the drawing horizontally. Okay, so like from where to where horizontally or in the axis we have the drawing. Like you could say, like for example, like I could try trapping the drawing from -4 to 2, like something like that. If you notice, like the drawing is escaping from you in this part, and you might think, ah, but I trap it in here. No, actually the drawing escapes always from this place, okay? You might be thinking, okay, so maybe I'm gonna use a greater space, not from -4 to 2, but for example, like from -7 to 7, okay? Because that covers a lot of space, okay? It's not gonna go, it's not gonna escape from 7. Well, if I go up enough in the drawing, okay, you can see that there's a moment where the drawing is gonna escape. Okay? That will be like somewhere around 14, 15, like the drawing escapes. And same way in this case, like at 7 it escapes on -7. So you cannot trap horizontally the drawing. In order to catch it, you will have to basically capture the drawing on the infinity, okay, from -infinity to +infinity, and that is when we say that the domain is R. Okay, so in this case the domain will be R. Now what about the range? If we focus on capturing the drawing, remember that range is capturing the drawing vertically, not horizontally, okay, vertically. So we need to focus on the y's. So is there a way to capture this drawing vertically? Yes, there is a way to capture it vertically, okay. The way to capture it will be using a net from -3, okay. Can you see, from y equals -3, from there upwards, okay. I capture the drawing because the drawing cannot escape this net, okay. So I know that the drawing is gonna begin on -3, but where is it gonna end? Because it's going up forever. It doesn't have an end, so I cannot say that I can capture it upward, but yes, downward, okay. So it will be from -3 to +infinity because it cannot be trapped upward. So the range will be from -3 to +infinity. So closed on -3 and open on +infinity. That will be the range. Okay. Now what's the type of function we have in here? Well, when you see a v, that's an absolute value function. So that's what you're going to put. Absolute value function. Okay. That will be the type of graph that we have. Now let's go with the growth intervals: increasing, decreasing, and constant. Increasing means the drawing is traveling up. So where is the drawing traveling up? You can see that the drawing is traveling up in this direction, okay? So from where to where? You might be thinking, ah, from -3. No. Remember that we analyzed this thing based on the entire drawing. From where on the entire drawing that thing is going up. If you say from -3, not exactly, because it's also going down in there, like from -3 up, that's the same way that is decreasing also. So no, we need to use more proper numbers. In order to do so, we could say that this entire region is where the drawing is going up. So this is where the drawing is increasing. From where to where? You can easily figure it out. From -2 on the axis to +infinity. So that's where the drawing is increasing. So increasing interval would be from -2 closed to positive infinity. Now what about the decreasing? Well, it's decreasing on the other area, okay? And this other side is decreasing, okay? Because it's traveling down from negative infinity, and it stops decreasing on -2. Then from -2 it starts increasing, so it will be decreasing from negative infinity to -2. So that will be the decreasing interval. It will be from negative infinity, open because we never close the infinities, okay? From negative infinity open to -2 closed. Now what about constant? This drawing is never horizontal. It's either inclined in a decreasing way or inclined in an increasing way. It's never constant. So the interval for constant, technically there is no interval for constant. That's easily represented with the empty set symbol, okay? Empty set symbol will be this circle with a slash, and I want you to notice that the slash is going in this direction. The slash is going in an increasing direction, it's not going in a decreasing direction. If you put the slash in a different way, then that's not the same symbol. It will be a different symbol for something else. Okay, so be a circle with a slash like this one. And that will be it. Those will be step 4, step 5, and step 6, which are the last steps for this exercise of the planning workshop.